In this unit, we're going to study polynomials. In this lesson, we're going to look at factoring trinomials where the leading coefficient is 1.
Okay, hi everybody. So in this lesson, we're going to take a look at trinomial factoring. And specifically, the kind of factoring we're looking at here is where that a value is equal to 1, okay? Now what we mean by that is we're talking about the leading coefficient. When we're talking about a trinomial here, the a value is the coefficient of the squared term here, okay? So in standard form, like it says right here, the form of a trinomial is going to be ax squared plus bx plus c. And we don't want a to be equal 0. A can be anything other than 0 here. Now, a and b are considered coefficients. Yep. C is going to be that constant. Yep. Okay, because it's sitting there all by itself without a variable multiplied through. The degree is going to be 2. And so as a result, we've got this leading coefficient of a here. What we want to do here is look at the very special circumstance here of factoring when, like we said before, a is equal to 1. Now, in a previous lesson here, we were talking about expanding, okay? And we know that expanding and factoring are basically opposites of each other here. So let's just take a quick look and talk about it again here. So we learned about FOIL. We've got two binomials multiplied together here. Now, remember the way this works here. The x gets multiplied by the x, the first term in the second factor there, the binomial. The x then gets multiplied by the second term in that second factor. Then the 4 gets distributed to the first term, and then the 4 gets distributed to the second term. So what we end up with here is x squared plus 3x plus 4x plus 12. Okay? And then, and this is always going to happen here when you've got it in this structure here, these two terms are going to be like. Okay, they're going to be like terms. And so we will add them together to get this middle term here. So notice that 7 is going to be 3 plus 4. Okay, and just to be clear, those two numbers right there. And 12 is 3 multiplied by 4. And again, we're talking about these two numbers over here. Okay? So now what we're asking you to do is to go backwards from that trinomial, from that x squared plus 7x plus 12, and go backward to the two factors that we multiplied together to get it. And so once we've done that, we can always use FOIL, okay, to check to see if we've done that right, to check to see if our factors that we are guessing here, or we're assuming are true here, are actually the factors that we're going to use there. Now, there are several types of trinomials that are going to be asked to factors, okay? So that's one of the things that we're going to look at moving forward here. But the number one rule here is to always look, always check to see if there's a greatest common factor first, and you should take that out first because it simplifies the work down substantially to get rid of a common factor if you see it. Additionally, if the leading coefficient is negative, and this isn't absolutely necessary, but it really does make a difference, take that out as well and rearrange the terms if you have to, okay? Put them in order. It's always good to have it in standard form, okay, where it's in the order of decreasing powers here. Okay, so now we're going to be factoring trinomials of the form, okay, ax squared plus bx plus c, where a is equal to 1. And so this is the kind of thinking that we got to go through. Actually, I'll go up just a little bit more here so we can kind of see everything. So when we're factoring it like this, remember that these two numbers right here, when I add them, I get the middle term. When I multiply them, I get that final term. Okay, so these two numbers, whatever, I don't know what they are, but when I add them, I get B. When I multiply them, I get C. Okay, so like in that previous case there, it was 3 and 4. So this was 3 plus 4 was equal to 7. 3 times 4 was equal to 12. Okay, that was just a specific example, but that's the thing that we have to unlock here. That's the idea. That's the pattern of thinking that we got to go through. So here we go, just to lay out some steps here before we do some examples, because really, until we start going through and doing examples here, it's probably hard to follow along here. But first thing we're going to do, factor out a greatest common factor if possible. And if that leading coefficient is negative, you might want to factor that out here. Then state the product. Okay, in other words, basically, I want you to state the last term, C, state the sum, that's that middle term, B, and now, and this is the hard part, okay, this is the part that is difficult about factoring here. And even before I go through and discuss this, I just want you to know that there are lots of different methods of factoring out there. But where they differ is in their structure and how they approach the idea of like organizing the material. And they try really hard to make it easy and straightforward here. But at some point in time, every one of those things, you've got to determine, you've got to think about two factors that have that product and have that given sum that we're looking for. And you got to be able to find those. The more comfortable you are with your multiplication tables, the easier this sort of thing is. But if you're fighting with your multiplication tables, this becomes very, very difficult. Okay. But anyway, from there, we create our binomial factors, okay, using the values here. And you it says it's optional here, but you really do want to check. You really do want to check to see that what you've got, what you've guessed there is going to multiply back and to the original question when you distribute it. Okay, so now let's take a look at some questions, because I think that's what we need. You need to see this kind of factoring in action, I think, before it'll really make sense. Okay, so here we go. We're being asked to factor the following fully here. Now, the first two questions are basically just going to lead us through this just a little bit. Okay, so we've got this x squared plus 10x plus 16. Whoops, sorry, I forgot to activate the pen. X squared plus that 10x plus 16. Now, first thing we want to do here is identify the product and identify the sum. So now I'm looking for two numbers whose product would be 16 and whose sum would be 10. Now, I really do want to focus on the product thing first. Okay, there's all sorts of numbers that'll add together, that'll combine to get 10. And in the same way, there's really an infinite number of things that'll multiply together to get 16, but we're looking for nice numbers that do that. So 4 and 4, for example, we might initially guess 4 and 4, but 4 and 4 don't add up to 10. So after a little bit here, I'm hoping that you'll see that it's got to be 8 and 2. Those are your factors of 16 that add up to 10. So what we're saying here is that x squared plus 10x plus 16, sorry about that, x squared plus 10x plus 16, this is going to factor down to x and x there, and then plus 8 plus 2. And we just put those numbers in here. And you can see when you expand that out that you would get x squared plus 2x plus 8x plus 16. And when we add those middle two terms together, we get x squared plus 10x plus 16. And so that worked. That was what I was hoping for here. Now, look at the next one here. A squared minus 11a plus 18. So my product is 18. My sum is negative 11. So the presence of that negative there, okay, suggests to me that something's going to be negative in here. And in fact, because the product is positive, it probably means that both of these numbers are going to be negative. So now what I'm really looking for here is two numbers that have a product of 18 and a sum of 11, and it shouldn't take too long to realize that that's got to be 9 and 2. Okay, negative 9 times negative 2 is positive 18. Negative 9 plus negative 2 is going to be negative 11. So that works here. So my factors become, we're going to start with a in both cases here. This is going to be a minus 9 and then a minus 2. And again, if you expand that out, I will get a squared minus 2a minus 9a plus 18. So a squared minus 11a plus 18. And that worked. Okay, that worked. That just showed that I did that factoring correctly here. Okay, so now let's take a look at some of these other problems where we're not given as much of a lead in here. Now, first of all, take a look at this one. And before I do anything with C here, notice that there's a common factor of 2 in each of those coefficients here. So I can factor that out. And that will get me p squared minus 9p minus 10. And now that's the trinomial that I really want to factor, because now the coefficient of the p squared is just 1. So now I'm looking for two numbers whose product is going to equal negative 10 and whose sum is going to equal negative 9. Okay, negative 10, negative 9 here. Well, notice that 10 and 9 are just 1 apart. And because the product is negative, one of these numbers is negative, one of them is positive. And because the sum is negative, and I know that this is kind of a lot of if this sort of thing, but if the product is negative, one of the two numbers is negative. If the sum is negative, then it's the larger number that's negative. So in this case here, this could be negative 10, for example, and 1, and negative 10, for example, plus 1. And that's where I'm getting the negative 10 as a product and the negative 9 as a sum here. And so I can factor that as 2 multiplied by p minus 10 and then p plus 1. Just in the interest of time here, I'm not going to bother expanding that out. That does work. For this one right here, for d, there really isn't a common coefficient, because the leading coefficient here is 1, but there is an a in every term. So I do want to factor out the a, and that gets me a squared minus 17a plus 42. So now I'm looking for two numbers whose product is 42 and whose sum is negative 17. Okay, so because the product is positive and because the sum is negative, I think these two numbers are going to be negative. They're both going to be negative. So a negative and a negative, negative and a negative. Okay, because two negatives multiplied together is a positive. Two negatives added together will be negative. Okay, now two numbers that have a product of 42 and a sum of 17. Now, this is not an obvious one. I suspect that you're probably don't have, even if you know your multiplication tables, odds are probably pretty good that you're not 100% sure of this one. So I'm just going to help you out here. The numbers here are going to be 3 and 14. Okay, so the trick is they are there. They are there, but you probably, yeah, you might not have known that to begin with, just off the top of your head here. But that's okay. I mean, you can always use your calculator to check these numbers if you want. And so now, don't forget that a that we pulled out initially, and then we're going to have a minus 3 and a minus 14. And there we go. We factored it. For question E, again, a quick look at it tells me, well, wait a minute, I've got coefficients with every term here, and they're all multiples of 5. So I can factor a 5 out. I can take out my greatest common factor is 5, and that's going to leave me with x squared minus 4x plus 3. So now I'm looking for two numbers whose product is going to be 3 and whose sum is going to be negative 4. Okay, so the product is positive, but the sum is negative. Okay, so again, I suspect that we're dealing with two negatives. Same reasoning as before. 3 and 4 differ by 1, so this is probably going to be negative 4. Sorry, not negative 4. I did that too quick. Whoops. Oh, sorry, I'm choosing the wrong spot. I'm grabbing from the wrong menu here. I want this to be, I want this to be a negative 3 and negative 1. Negative 3 and negative 1. Okay, multiply those together, you're going to get positive 3. Add them together, you get negative 4. So then leave the 5 out front. X minus 3, x minus 1. Okay, and as I'm sliding this up here to kind of reveal some more questions, I do recognize that this is a little bit complicated, okay? That these, again, coming up with those numbers with the appropriate product and the appropriate sum, that is a difficult thing to do. All right, now let's keep going here. So x squared plus 7x plus 6. Now notice there's nothing common for us to take out, so we can kind of jump right to our product and our sum here. So we're looking for two numbers, again, whose product is going to equal 6 and then whose sum is going to equal 7. Okay, and I think about that, and actually, they're one apart here. Notice that this product and the sum are both positive, so everything here is going to be positive. So this is just going to be 6 and 1, 6 and 1. So our factors will become x plus 6, x plus 1. Okay, just make that equal to. Whoops, that doesn't look quite right here, so let's just change that. We'll fix that up there, make her look pretty there. There we go, a little bit better. Okay, so here, again, there's with a squared minus 2a minus 35, there really is nothing common that I can pull out here. So I'm going to look at my factors here. So I need two numbers that multiply together to get negative 35, and whose sum is going to be negative 2. Okay, so negative 35 is the product. So one of them is negative, one of them's positive. The sum is negative, so it means the larger number's got to be the negative of the two. And 35, as soon as I think 35, I'm thinking 5 and 7. And again, because of what I said, that would have to be negative 7. So 5 and negative 7. And yeah, when I add those together, I'm going to get negative 2 here. And so my factors would be a plus 5 and then a minus 7. Awesome. Now over here, for this one right here, I'm not particularly fond of the way that's written. It doesn't look quite right to me. So what we're going to do here is, first of all, we're going to change the order so it kind of matches the order of the questions we've been working with thus far. And then I notice that there's this common negative to everything. Now, more importantly, there's a negative as a leading coefficient, and I'm not particularly fond of that. So I'm going to take it out. Okay, and there we go. Actually, I'm going to clean that up just a little bit there. So plus 36. Now, I'm looking for two numbers whose product is 36 and whose sum is going to be 12. Now, don't think too hard on that one, because turns out it's going to be 6 and 6. And notice both the product and the sum are positive, and so the two numbers that we're working with are also going to be positive. So this is going to become negative, because don't forget about that negative we had in there. A plus 6, a plus 6. Or if you want, you could write it as negative a plus 6 squared. Okay? Now, next one. Let's go down here. Is there anything common to all three terms? The answer is no. No. But this one is a little different because of the y in there. So, but notice that my terms are x squared, x, no y, y squared. Basically, we've got the exact opposite thing going on with x and y. So after I go through and do this, that should kind of prep you for what this is going to look like in future work here. But first of all, actually, let me clean this up a little bit. Let's go through and we'll just factor it. We're just going to pretend right now that the y's aren't even there, quite honestly, because I really don't need to worry about those until the end here. So I'm looking for two numbers whose product is going to be negative 36 and whose sum is going to be negative 9. Okay. Now, turns out that's actually not that hard to do here. Now, the product is negative, so one of them is negative, one of them is positive. The sum is negative, which means the bigger number is negative. In between those two here, that's got to be negative 12 and positive. Whoops. Well, okay, I'll just write it out here. Positive 3. So negative 12 and positive 3. And so what we're going to get here is, okay, x minus 12, x plus 3. Now, I haven't addressed the y's in there, but the y's behave like the x's in the opposite order. So it turns out we can get that to happen by just plugging the y's in right here. And that's how you would address that. And if you multiply this out, you'll see what I mean. In fact, let's do that. So we're going to get x times x is x squared. X times 3y will be 3xy. Negative 12y times x will be negative 12xy. And then negative 12y times 3y is going to be, negative 36y squared. And so you see when you expand that out, now you'd add together the middle terms, but you see when you expand that out, you do get that original expression there. All right, now this one, when I take a look at it, oh, I got a cube in there and whatnot. But notice I can take out some stuff that's common. First of all, there's a common 2 to every coefficient. And not only that, but there's a common x. And after I take that out, that leaves me with x squared plus 20xy plus 100y squared. So I've got this x and y relationship going on here. Oh, oops, sorry, I didn't want to write equals here. I want to figure out what it is I'm looking for. So I'm looking for two numbers whose product is 100 and whose sum is 20. And actually, that one's pretty easy because most of us, by default, when we think about numbers that have a product of 100, we think 10 and 10. Yeah, a lot of people do. So it turns out this is actually going to be 2x multiplied by x plus, and remember what we do here, 10y, x, whoops. Wow, why did I do that? Okay, not 10 there. Okay, it's going to be x plus 10y. Okay, and there you go. And you could write that 2x times x plus 10y squared if you wanted. And now finally, last but not least here, we have got, well, first of all, notice that the leading coefficient is negative. So I'm going to want to take that out. There's a factor of 3 common to all three of those terms, and there's an x in every one of those terms there. So wow, we got a lot going on here. But this is going to now simplify to x squared minus 7x plus 12. And now I'm looking for two numbers whose product is 12 and whose sum is going to be negative 7. Now, if the product is positive, but the sum is negative, that means both of these numbers are going to be negative. So we're looking at negative, 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 negative. And actually, this one here, if you're somewhat comfortable with your multiplication tables, you know that this is going to be 4 and 3, 4 and 3. Okay? And so this becomes x minus 4 and then x minus 3. And again, we can verify that by multiplying that out. So, and I know I said it a couple of times, but I'll say it again here. The factoring can be difficult, okay? It can be hard to find those two numbers. So don't be too upset with yourself if you struggle with that. That's okay. Just keep plugging at it. Do the best you can. Yeah, I hope this has helped a little bit.